In this video, we're going to begin the conversation about quadratic functions with some of the vocabulary associated with quadratics. And this U shape is a quadratic, just like the absolute value function, which was a V. Quadratic functions are U-shaped. So we're going to start with this idea of maximum value and minimum value. It's the same as what we did before with absolute value functions. So this is the y value at the top of the hill. And you can easily see the example here is this would be the y value at the top of the hill. So in this graph, that would be 1. Minimum is the exact opposite of that. So it would be the y value at the bottom of the hill. And in this case, there is no bottom. So if there's a maximum, there is no minimum. But if there's a minimum, there is no maximum. So you can see that the U shape either opens downward or the U shape can open upward, which gives you a maximum or a minimum. And so those two things are connected. The next vocabulary word is something that we also know. It's Xintercept, and it's just the values of x where the function crosses the x-axis. Okay, so it's just the values of x where the function is this U shape, crosses the x-axis. So we have one here and one here. And so in this case, it's the set of numbers 1 and 3. Okay, and so there's other ways to write that. We could write each of these as a point. For example, 1, 0 or 3, 0. And so those are two different ways of representing the same idea. And so if x-intercepts are the values of x where the function crosses the x-axis, y-intercept are the values of y where the function crosses the y-axis. Now remember, if you're having difficulty reading this, or if you need for me to repeat things, you can just rewind. So the value of y where the function crosses the y-axis, and in this case, it's that same exact idea here. So I could do two things. I can write this as a point 0, -3, or I could write it as a set, 0, -3. I can write this as a set -3. Once again, vertex is the exact same as what we did before with the absolute value function, that point at the very top or that point at the very bottom. So in other words, these max and min values can be useful in finding pieces of the vertex. And as you see, the max value here is the y for this vertex. And so the vertex is the point at the max or min. Okay, it's just that point at the max or min. And in this case, the x is 2, the y is 1, and so we have 2, 1. And this I have to write as a point because it's an x and a y value. It's not just one value or the other. It's a point. Axis of symmetry is the exact same, again, as the absolute value function, where we took that vertex and looked at the x value, and it divided the left half and the right half from each other. So this line right here, the axis of symmetry divides the left and right half, and what we want is x. So axis of symmetry is the x value where the function is symmetric. Okay, and in this case, the left and the right max each other at x equals 2. And remember, you can take this from the vertex. So anytime that you have the vertex already, you know the axis of symmetry. Now, some functions don't have the axis of symmetry that's at a vertex because they don't have a vertex. But we'll get to that in later functions. Okay, domain, once again, it's the exact same idea for domain and range. It's all x values from left to right. Okay, and then the range is the same idea but for y. So all y values from top to, sorry, that's backwards. All y values from bottom to top. And so if I'm looking at this function, the x values are going to continue to go and go and go in both directions forever. And so my domain is negative infinity, comma, positive infinity. And this is true for all quadratic functions. So just here I'm going to put true for all. True for all. Okay? Now, the range, just like absolute value, depends on where this maximum is or where the minimum is. If it's a maximum, everything has to be below it. If it's a minimum, then everything has to be above it, because that's what a max or a min means. And so in this case, the range starts way, way down here because the function is going to continue going down, 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 down. It continues forever. And since it continues forever downward, we know that it starts the bottom, which is negative infinity. Then it reaches a point where it has a maximum, value, which is right here at 1. And so I can use my max to help me find that value, or my min to help me find the value. Okay?